So I hope screen is visible.
Yes, sir.
Okay. Okay, so I will wait for a few minutes so that other people will join. Then we will start. Just wait a minute. So I will just create another meeting link so that if it gets end after 1 hour, so we will use this meeting link. Yeah, so I will write it down here. Okay, so I will start now. So, hello everyone, welcome to all. My name is Abhishek Pandey. I'm a Prime Minister Research Fellow in the discipline of Mathematics at IIT Bhubaneswar. And today we are going to talk about week 5 assignment. So basically week 4 assignment I have uploaded on YouTube, YouTube link. You can go through and the lecture notes also. Okay, so yeah, recall some basic facts. So this we will recall. So C comma D is a metric space, this complex plane with this metric modulus d of x comma y is equals to modulus of x minus y. Okay, so a curve is a continuous function and the length of curve is denoted by this. Okay, yeah, and where the supremum is taken over all the partitions P. Okay, so you take the partitions and you take the supremum and so you calculate this summation. Okay, if length, so we'll denote the length of gamma like this. If length of gamma is less than infinity, the curve is said to be rectifiable. Okay, and if gamma is a continuously differentiable curve or piecewise continuously differentiable, then gamma dot t is continuous. And yeah, it means the continuous differentiable means this one, gamma dot t exists and gamma dot t is continuous. So if gamma dot t is non-zero for every t, gamma is said to be smooth. Okay, so to distinguish between continuously differentiable and smooth, this is the condition we are imposing. Yeah, so in this case the length of gamma is simple to calculate. I mean actually we have a formula for this one. So length of gamma is nothing but integral over gamma mod dz, which is nothing but integral a to b mod of gamma dot t dt. Okay, yeah, so let gamma such that a comma b to c is a rectifiable curve. Okay, so rectifiability I already mentioned, means its length is less than infinite, means its length is finite. And f says that gamma of a comma b to c is a continuous function. Okay, so then for a partition we define this Riemann sum. I mean this we are giving the definition of line integral of f. Okay, so this is the Riemann sum f of gamma tj star and gamma of tj minus gamma tj minus 1. So now the theorem says that for given epsilon greater than 0, there exists a delta such that uh, this quantity there, so I minus this is less than epsilon whenever this norm of p is less than delta. Okay. Wait. Yeah. So yeah, so whenever this norm of p is less than delta, and we denote this I as a integral of f over gamma, is said to be the integral of f over the curve gamma. Okay, so we have some properties. Recall these properties. So let gamma such that a comma b to c is a rectifiable curve and f is continuous on the image of the curve gamma. Then integral over gamma of fz is nothing but integral over integral of f over any parameterization, reparameterization of this curve gamma. Okay, and if you take the reverse path, this integral sign changes. Okay, and if you take the addition of these two paths, gamma and gamma 2, this will be separated. So integral over gamma 1 plus gamma 2 of f is nothing but integral of f over gamma 1 plus integral of f over gamma 2. Okay, so we have the change of variable formula, which is known as this integral of f over the curve gamma when gamma is continuously differentiable. So this will be denoted by this integral over a to b f of gamma t into gamma dot t dt. Okay, so this is the formula to calculate the line integral. Okay, so this is used when f is if gamma is continuously differentiable, because here we are using gamma dot t. Okay.
Excuse me, sir.
Yeah,
In the
anything?
first property, can you able to give some example for the first property, sir? Reparameterization you have said, sir.
Just wait. Yeah, so if so, I hope you know the definition of reparameterization. So basically, reparameterization means we are just parameterizing this interval. Okay, so it means that there is a s continuous onto and non-decreasing function. So suppose we have this reparameterization gamma bar. Okay, and you if your f is any continuous function, then this reparameterization, the integral over this reparameterization will be same. So basically for a continuously differentiable function, you can basically just calculate this one with this formula. So suppose if you have a reparameterization of gamma, say gamma bar, so integral over gamma bar fz dz will be f of gamma by t and gamma by dot t dt. Okay, and again this will be once you change this one, like you have to change the parameter t to u. Suppose so this gamma by t is nothing but the composition of gamma with some h. Okay.
Yes, sir.
Yeah, so in that case, once you take the differentiation, it will be nothing but gamma dash st into s dot t. Okay, so in that case, this gamma bar will be your, I mean this integration will be the same. If you want to see, just let me go through here. I will just show you the method. Yeah, so just wait a minute. So this is the week 4 assignment thing. Let me just go through the solution here. Yeah, so no, not yet. I think this is the one. Okay, yeah. So this is your reparameterization. So if gamma 1 is a curve and gamma 2 is a reparameterization, so what does it mean? So it means that there exists a continuous onto a non-decreasing function such that gamma 2 can be written as the composition of gamma 1 composition h. Okay. Now, so wait a minute. So you just see how do we calculate this. Wait a minute. Yeah, so here gamma 2 T is equals to gamma 1 composition ST. So gamma 2 T is will be gamma 1 composition H of T. Okay. Now, yeah, so here if you go, so if you take any continuous function, wait a minute. Where it is. Yeah, so just see what is the length, no, not length. So let me go to the definition of this one. Yeah, so if you see this one, this is the definition of this integration, isn't it? So if you take any reparameterization, you take tj star, so this tj star will correspond to some h of something t, let us say tk star. Are you getting this one? So integral over this, wait a minute. So integral over this gamma bar. So gamma bar is nothing but gamma of h, gamma composition h. Okay. Hello.
Okay, sir.
Yeah. So gamma bar is nothing but gamma composition h. Now once you calculate this integral over gamma bar, so here you have to take gamma bar some tj star. Now this tj star is nothing but so this sorry this gamma of so this gamma of tj star is nothing but something h of tk star, isn't it? Okay, and similarly this will be gamma of h of tj and gamma of h of tj minus 1. Now now since your h is continuous and basically non decreasing, this is this summation modulus will again will be less than epsilon. Okay.
Okay, sir.
Yeah, so okay, anyhow in the notes I will include the proof. There is no problem. I mean, basically, the reparameterization doesn't change the integral. Okay. Yeah. I hope this is visible. Anyhow, I will read it down. So, primitives slash antiderivatives, primitives or antiderivatives. So, if f such that omega to c be any complex valued function, a function is said to be primitive of f if f such that omega to c is analytic and derivative of f is equals to a small f. Okay. So, yeah, so this is kind of known as the first fundamental theorem of calculus in the complex plane. Suppose that f such that omega to c is continuous and f has a primitive, say capital F. If gamma is any piecewise smooth curve in omega, then this integral over gamma of f is nothing but capital Fz gamma a to gamma b, gamma a from gamma b. Okay. So in the real valued case, we know that every continuous function has a primitive. What is the way to define a primitive? I mean, this is just a standard thing. So if f is continuous, you define this function g of x is equals to integral a to x ft dt. Okay, and we know that this g is uh, this is a standard fact that g is differentiable and g dash x is equals to f of x for every x belongs to ab. So this g is primitive of f. Note that every continuous function has a primitive, but every analytic function need not to have a primitive. Okay, means it is not true that every analytic function has a primitive. Okay, because if you think the way we have defined the primitive in the continuous function case, I mean the real valued case, so f is continuous, we have defined the primitive like this: g of x is equals to integral a to x ft dt. Okay, and we have proven that z is differentiable and g dash x is equal to f of x. Similarly, we can do in the complex plane also. Okay, so you take any path from a to x and integrate over that path. But the thing is that this function will not be so. In the case of real valued, this function is well defined. Okay, because you have only one path from a to x. That is nothing but a line segment. Okay, So line segment joining A to X, that is the only path you are having in the real line. But once you are in the complex plane, you may have different paths from A to X. Okay, so if you take a path from A to X, the integral will be something you will get as an integration. But if you take another path, the integration might get changed. Okay, so this function may not be well defined in the complex case. Okay, so uh, so via this way we cannot define the primitive of every I mean to say analytic function. Okay, so for that we need some conditions on the domain, so that this function, the way we are defining here, that will be well defined. Is it clear, the primitive case? Because this is quite important, we will use later on in Cauchy's theorem or everything. Okay, so the next thing is on the existence of primitive. So recall that what do we mean by a polygonal path? So polygonal path is the connection of a straight lines. Okay, so a straight line curve. So from Z1 to Zn, it will be Z1 to Z2, Z2 to Z3, and so on, Zn minus 1 to Zn. Okay, so polygonal path is a straight line curves. Now the existence of primitive. So let omega be any domain, and let f such that omega to c be a continuous function such that integral of f over this gamma is 0 for every polygonal path gamma contained in omega. Then f has a primitive in omega. So what is the idea of the proof? So fix z0 belongs to omega and define capital Fz as integral over gamma f xi d xi, where gamma is a polygonal path joining z0 to z. So now the thing is to show that f is well defined. So how f is well defined? So suppose you have taken a fixing a point z0 and you take a point z. You take a polygonal path from z0 to z. You take another polygonal path from z0 to z. Now this combined structure is nothing but again a closed polygonal path, isn't it? Now on this whole thing, the integral of f will be 0. So going from this to this and again from this to this, integral over this will be equal to this one. Okay, because integral over this plus this will be 0, will be equal to 0, and this integration will be the change of sign. Okay, and again then calculate the derivative. So this is the way, this is the idea to prove that this is the idea to prove the existence of, see, we are doing the same thing. Fz is equals to integral over gamma f xi d xi, the way, so the idea is same the way we are doing in the real case. Okay, but the only thing we have to make sure that we have to be uh, the the only thing we have to take care about is that this function has to be well defined. Okay, I hope this is clear. Okay. Okay, so let us look at the problems. Okay, so suppose f is a continuous function or a continuous function omega, then the following are equivalent. Then which of the following statements are true? So the curve gamma such that 0 to 1 to c given by this is a rectifiable curve. So let us calculate this one. So gamma of t is defined as 0 when t is 0 and t plus it sine 1 by t for t is non-zero. So length of the gamma is nothing but this one. Okay. Now you take any partition. So if the curve is rectifiable, this length should be finite. Okay. So what does it mean of having the length finite is rectifiable? So it means that gamma is a bounded variation if and only if xt and yt are of bounded variation. So gamma t is equal to xt plus iot is of bounded variation if and only if this xt and yt are of bounded variation. So basically this gamma of t this gamma is rectifiable is same as saying that this gamma is of bounded variation. So we will prove that this gamma t is not of bounded variation. This is a standard fact in real analysis, that this kind of function is not of bounded variation. So we consider function ft is equals to t sine 1 by t. So f is not a bounded variation. So basically you take tn is equals to 1 upon n pi plus pi by 2. So this is the partition we are taking. 1 upon tn will be this one, and f of t, so sine of 1 by tn is this, and f of tn is tn when n is even and minus tn when n is odd. Now you calculate this one, summation. Okay, so this you will get as summation. So summation n equals to 1 to m tn plus tn minus 1, okay, is equals to, yeah, so this you will get tm plus t naught plus 2 summation n equals to 1 to m minus 1 tn, which is greater than equals to summation n equals to 1 to m minus 1 tn. Then what is your tn? Tn is this. So this will be summation n equals to 1 to m minus 1, 1 upon n pi plus pi by 2. Now this tends to infinity as your m tends to infinity. Okay. So in general, these kind of functions are not of bounded variation. Okay. Yeah. So this is not of bounded variation. So it means it is not rectifiable. This curve is not rectifiable. Okay. So this is again a simple thing. So given a rectifiable curve, we have this one. Okay. So this follows from here only, which I mentioned earlier. Yeah, this one. So suppose supremum of this is less than is equals to m, then integral over, so integral of f over gamma modulus is less than equals to m of length of gamma. Okay. So this is also true. Again, for a smooth curve, we have this formula for integration. Okay. Okay. Let f comma g be functions continuous on omega and gamma such that ab to omega be a rectifiable curve. Then integral, so integral of f plus g over gamma will be separated. So so this will be integral of f over gamma plus integral of g over gamma. Okay. Now the next question is, let gamma be a rectifiable curve and gamma bar be a reparameterization of gamma. So then integral will be the same. Okay. Yeah, and this one is let gamma and sigma be rectifiable curves such that the terminal point of gamma is the initial point of gamma. So this is basically nothing but, so suppose you have this curve gamma, and so the terminal point of gamma will be initial point of the sigma. Okay, so the integral will be separated. So integral of f over gamma plus sigma is nothing but integral of f over gamma plus integral of f over sigma. Okay, so this problem is done. Let us look at the next problem. Yeah, so if gamma such that 0 comma 1 to c given by gamma t is equals to e to the power 2 pi iota t, denote the unit circle, then integral of f integral of 1 by z over gamma is 0. So this is not correct. Okay, so integral of gamma integral of f integral of 1 by z over gamma is nothing but integral 0 to 1. So this again you have to apply the formula. So f of gamma t into gamma dot t. So this will be nothing but 2 pi I e to the power 2 pi iota t upon 2 pi iota t dt. So this will be 2 pi I. So hence it is not 0. Okay. So this thing is correct. Now let us look at the 1 by z square. So you again apply the same formula, f of gamma t into gamma dot t. So integral over 0 to 1, this will be f of gamma t will be this one, and gamma dot t will be 2 pi I into, yeah, 2 pi I into e to the power 2 pi iota t dt. So this will be 2 pi I and integral will be this one. Now again you calculate, so this will be nothing but 0. Okay. Now the next thing is, yeah, so if gamma is a rectifiable closed curve in omega, then integral over gamma e to the power z dz is equals to 0. Yeah, so here one thing I need to mention here that, so what we have seen that in the rectifiability theorem, this one, oh, sorry, this fundamental theorem of calculus, first version. So suppose that f says that omega to c is continuous and f has a primitive. Okay. If gamma is any piecewise smooth curve, then integral of f over gamma is nothing but, so it will depend upon the endpoints of this one. So this will be nothing of capital F of gamma of B minus capital F of gamma of A. Okay. So now it means that if this curve is closed means initial point is same as the terminal point, means gamma of A is same as gamma of B. So f of gamma of B minus f of gamma of A will be 0. Okay. So if you have a primitive, the integral, so if you have a primitive of a complex valued function, the integral of that complex valued function over a closed rectifiable curve will be always 0. Okay. Is it clear? Yeah. So so now e to the power z always has a primitive, that will be e to the power z only, or constant, or with the with some translation, e to the power z plus c. So e to the power z dz is equals to 0 for every closed curve because it has a primitive here. Okay. Now let f be a function continuous on omega and gamma be a rectifiable curve. Which of the following are true? So integral of gamma of f is equals to minus over integral of minus gamma of f holds only if gamma is a closed curve. So this is saying only if. Okay. So which is not true. Let gamma be any rectifiable curve, then this one is true. Okay. So you have a you have a curve gamma. So it's if you trace it back, the integral over that will be minus sign. So let sigma such that 0 1 to omega is another rectifiable curve such that gamma of 0 is equals to sigma of 0 and gamma of 1 is equals to sigma of 1. Then integral of f over gamma is integral of f over sigma. So this is not correct. I mean, you just take any curve gamma and you just take any curve sigma. So you take fz is equals to 1 by z. Okay. So integral over c of fz is equals to 2 pi I. Okay. And you take the gamma as this one upper part and sigma as the lower part. So this difference will be 2 pi I. Okay. So this will be so this gamma, so this integral of f over gamma will be 2 pi I plus integral of f over sigma. Okay. Okay, this is the important question. So let omega be c minus 0. So let omega be a punctured complex plane. Then the function fz is equals to 1 by z has an antiderivative in omega. This is not true. So it says that 1 upon z has an antiderivative in omega. This is not true. If at all it has an antiderivative, it means that the integral will be 0. So it means that, so you take any, so you take c minus 0 and you take this curve unit circle. So if 1 by z has a primitive in c minus 0, it means that this integral will be 0, which is not the case. Integral of 1 by z over the curve mod z equals to 1 is 2 pi I, which is non-zero. So 1 by z does not have primitive in omega. So it means that this last option is true. Okay. Yeah, let us look at this problem. So let f comma g be holomorphic functions on an open bounded connected set omega, and let gamma and sigma be rectifiable curves whose image completely lies in omega. Then which of the following statements are true? Okay, suppose that gamma is a polygonal path starting from 0 and ending at 1 plus I, and sigma is another polygonal path starting from 1 and ending at 2 plus I. So see, this is what we mean by polygonal path, from this to this. So this will be a straight line. You join by straight lines, different. Okay, so let us look at the problem. So let gamma is a polygonal path starting from 0 and ending at 1 plus I. Okay, so this is 0, this is 1, this is 1 plus I, and this is 2 plus I. So this is a polygonal path. So 0 to z1, z1 to z2, z2 to z3, then again you will go to 1 plus I. Similarly here also w1 to w2, w3, and again wn minus 1, and then you will go to 2 plus I. Recall that this gamma plus beta is equals to this one, integral over fz over gamma plus integral of f over beta. Now what is this gamma? This gamma is nothing but the line segments joining 0 to z1, then z1 to z2, and again zn minus 1 to 1 plus I. So what would be the integration? Integration will be e to the power z on this one, and again on this one, plus, and so on, plus integral of e to the power z over zn minus 1 to 1 plus I. Yeah, so what would be this one? So this will be, again, it has a primitive, so e to the power z1 minus e to the power 0. So this will be e to the power z1 minus 1. This will be e to the power z2 minus e to the power z1. Again, here will be z3 to z4. So sorry, z2 to z3. So e to the power z3 minus e to the power z2. Again, e to the power 1 plus I minus e to the power zn minus 1. So overall this will be, so e to the power z1 is cancelling out, so everything will be cancelled out. The only thing left will be e to the power 1 plus I and minus 1. Okay, and similarly for sigma you will take this one. So this will be again so this will be e to the power 2 plus I minus e, so which will be e into e to the power 1 plus I minus 1, which is nothing but e into e to the power z over gamma dz. Okay, so this thing is not true, this option. I mean, sorry. So this option is correct. So integral of e to the power z over sigma is nothing but e into integral of e to the power z over gamma. Okay. So this we will get here. Okay. So is it clear, this integration process? Okay. So integral of f into z over gamma is separated like integral over f, yeah, integral of f over gamma into integral of g over gamma. So this is not correct, we will see this later. Yeah, so let omega be a domain which is nothing but omega is nothing but 0 to 2, mod z is greater than 0 and less than 2, and gamma is your unit circle. Okay, you consider fz is equals to 1 by z and gz is equals to 1 by z. Both are holomorphic in omega. Okay, so so f into g is nothing but 1 by z square over dz. So earlier we have seen that integral over gamma dz by z square is equals to 0, but integral of f over gamma is 2 pi I, and integral of g over gamma is again 2 pi I. So that will be 4 pi square, so minus 4 pi square, which is not equal. Okay, on the other hand, this is there, integral of fz over gamma is 2 pi I, so RHS is equals to minus 4 pi square, which is not equals to 0. Okay, so this option is not correct, option 2. Yeah, so if next option is if fn is a sequence of continuous functions on omega which converges uniformly to a continuous function f on omega, and if gamma is rectifiable curve, then this happens. Okay, so this is nothing but we have to just use the definition. So let fn be a sequence of continuous function on omega which converges uniformly to a continuous function this. So for a given epsilon greater than 0, there exists n naught belongs to n such that integral of fn over gamma minus integral of f over gamma modulus is less than epsilon for every n is greater than equals to n naught. Now what is this? This will be nothing but less than equals to integral of fn z minus f of z mod dz. Since fn converges to f uniformly, this can be you can bound less than epsilon over length of the curve gamma, because gamma is rectifiable. So equation 1 becomes this one. Now this is nothing but length of the gamma, so this will be less than epsilon. So just you have to use the epsilon property. So this integral over gamma fn z dz minus integral over gamma fz dz is less than epsilon. So it means that integral of fn over gamma converges to integral of f over gamma. Okay, so let f1 and f2 are two primitives for f where omega is connected. So how these primitives are related? So yeah, so omega is connected. So f1 is primitive means f dash z is equals to small fz, and f2 is primitive, so f2 dash z is equals to small fz. Now let g be a function defined by gz is equals to f1z minus f2z. Okay, so this g1z will be 0. Okay, because f1z is nothing, so f1 dash z is nothing but fz, and f2 dash z is nothing but again this f dash z is nothing, f2 dash z is nothing but fz, so this will be 0. It means that gz is constant, so it means that these two primitives differ by a constant only. Okay. Now let us look at the last question. So consider the power series f given by fz is equals to 1 plus summation n equals to 1 to infinity minus 1 to the power n, n to the power 4 minus 1 into z to the power n. Okay, so for any z belongs to the d unit days, suppose gamma is a straight line from 0 to z, and define gz is equals to gamma from 0 to z f of w dw for every z. Suppose g has a power series expansion given by this one. What would be a of 83? Okay, so let us solve this problem. Okay, so consider the power series, this one. This is the power series which has been given to us. Now let gz is equals to integral from 0 to z. So this is your line segment from 0 to z, and gz is equals to this. So now if gz is like this, it means g dash z is equals to f of z. Okay, so g dash z is nothing but this f of z. Now what would be now what exactly g dash z is? G dash z is nothing but, so this differentiation of a naught will be 0. So a1 plus a2z to the so this is a naught plus a1z plus a2z square. So this is differentiation will be a1 plus 2a2z. So in general, this will have this power series expansion. G dash z is equals to a1 plus summation n equals to 2 to infinity n a n z to the power n minus 1. Okay, and this g dash z is nothing but equals to f of z. Okay, so you just equate it with f of z. Okay. So you will get that 83, yeah, so 83 into a 83 is nothing but, so once you put 83, this you will get as 82. Okay, the power of 82. So here you have to calculate the power of 82. So 82 to the power 4 minus 1 into minus 1 to the power 82. So you will calculate this one and you will get this is just a calculation. So this is the idea. So here again we are using the primitive, like if you define like this, if you define gz like this is again becoming the primitive of f. Okay. Okay, so let's just look at this one. So let gamma be a closed path from z1 to z2, z2 to z3, z3 to z4, and z4 to z1. Okay, so this is your z1 1 minus I, this is your z2 1 plus I, this is your z3 minus 1 plus I, and this is your z4 minus 1 minus I. Okay, then what would be this integration? 1 upon 2 pi I integral of 1 by z over the curve gamma. Okay. Okay, so 1 upon 2 pi I integral of 1 by z over the curve gamma is nothing but 1 upon 2 pi I integral of 1 by z over curve gamma 1. Okay, and integral of 1 by z over the curve gamma 2. same over the curve gamma 3 and plus over the curve gamma 4. Now we have to parameterize it. What is your curve gamma 1? So this is gamma 1 from minus 1 minus I to 1 minus I. So this is nothing but x minus I. Okay, x is in minus 1 to 1. What is your gamma 2? Gamma 2 is nothing but a straight line from 1 minus I to 1 plus I. So again this is nothing but 1 plus IY, where y is in minus 1 to 1. What is your gamma 3? So gamma 3 is a straight line from 1 plus I to minus 1 plus I, okay, which is nothing but x plus I, okay. And again gamma 4 is nothing but minus 1 plus IY, okay. So this integral will be 1 upon 2 pi I integral over gamma dz by z is equals to 1 upon 2 pi I integral from minus 1 to 1 dx upon x minus I plus integral from minus 1 to 1 I dy upon 1 plus IY, and again and minus integration minus 1. So why we are getting minus 1? Because we are taking here the negative sign, okay. Because this we are retracing the curve, okay. Okay, so because here if you see gamma 3, this curve is going from 1 to minus 1. We want it from minus 1 to 1. So this integration, so this sign will be minus 1. So integration, so minus integration from minus 1 to 1 dx upon x plus I minus integral from minus 1 to 1 I dy upon minus 1 plus IY. So this is nothing but 1 upon 2 pi I integral minus 1 to 1. So this will be, so this is just integration, you have to calculate this one, and yeah, so after calculation this you will get, and which is nothing but equals to 1 upon 2 pi I minus 1 to 1 2I upon 1 plus t square plus 2I upon 1 plus t square dt. So this is nothing but 1 upon 2 pi I into 4I integral minus 1 to 1 dt upon 1 plus t square, which is nothing but 2 upon pi tan inverse t minus 1 to 1. This is again 2 by pi into pi by 4 plus pi by 4. So this is nothing but pi by 2. So pi by 2 into 2 by pi is 1. Okay, so this is done. Yeah, so we are done with the problems. If you have any question, please ask me. So this week 5 doesn't contain that much material, so yeah, so if you have any doubt or question, just please ask me. Yeah, Minal, do you have doubt any? And do you have any doubt?
No, sir.
Okay. Yeah, so this is done in between 1 hour. So yeah, so we'll meet for the next. So we'll meet for the next assignment on next Sunday. So I will close the meeting. Okay. Thank you.